All right, beautiful people. I am going to project our notes and we are going to graph quadratics that are in vertex form. So today is actually day 18. I know it says 4.7. That's from when I taught it before. This is day 18. That's what your notes should say. And I'm ready to get started. So I need you guys to focus. The graph of a quadratic is also called a parabola. It's spelled parabola. The graph of a quadratic is a parabola. If you're spelling it, it spells like parabola. And it looks like what letter? What does a graph look like? A U. The letter U. Yep, the graph looks like the letter U.
Like this.
Yes, it looks like the letter U. Looks like the letter U. So I'm going to go through, we already did this last class. So this is, and I know we've slept a lot since then, but this is vertex form and the vertex is HK. So that's what I wrote right here as vertex. It's H comma K. Before I ever even graph anything, I can tell you what the domain is because every single quadratic that we graph in here, it's going to be all real numbers. So you can even at some moment look at your homework and anything that it asks you about the domain, it's all real numbers. I will tell you that quadratics do exist that aren't just like this. They also go on their side like a C. We're not going to graph those, but they do exist. So I do want you to know they exist, but we're not going to graph them here in on level algebra 2. When we go to make our graph, we're going to start with our vertex, and this is going to be the parent function. So I'm going to graph the parent function. Y is equal to x squared. There's no transformations. There's no stretching, reflecting, shifting. It is the parent function. The parent function is going to start at 0, 0. So I'm going to put a point right at 0, 0. From here, because the parent function is x squared, we're squaring the x values every time. And so just like other functions, we're going to make the right half first, and then we're going to come back around and make the left half with symmetry because they're a symmetrical graph. So what I'm going to do is first go over 1. I'm going over 1. What's 1 squared? 1. That's how far up I go and make a point. Then I'm going to go over 2. And I just follow from my original vertex point. I go over 2. Well, what's 2 squared? 4. I go up 4. From that bottom line where the red is. It has to be even with the red, and then I count up 4. Now I'm going to go over 3. Well, what's 3 squared? 9. So it'd be up here. It'd be off my graph. So I'm going to use symmetry to make the ones on the other side. So I'm going to go to the left 1, and 1 squared is 1, and I'll put a point. I'm going to go to the left 2. 2 squared is 4, so I go up 4, and they're symmetrical on both sides. When I connect my dots, these are not a V. It doesn't make a V shape. It makes a U shape. So really at that vertex, around the vertex, you want to make sure it's a curve, not straight lines coming down like a V. So I'm going to connect my dots, and I'm going to try really hard to make it look like a U and not like a V. And it's easier for me when I draw it in two different pieces. Is everybody good with how I made my parent function graph? And we're going to get lots of practice. Most of the stuff down at the bottom is a complete review of what we did last class. So first, it says the y-intercept is when what is equal to 0? X. X is equal to 0. And it's where the graph crosses the which axis? Y. The y-axis is where it crosses the y-axis. Sorry, the y-intercept is where you cross the y-axis. The vertex is going to cut the graph in half. The vertex cuts the graph in half and represents the which or which point. Do y'all remember? It's going to represent the minimum or maximum point because it's either the top or the bottom of your graph. The axis of symmetry always goes through the vertex point. And it's always x is equal to h. So if you know your equation, you can tell me the axis of symmetry because it's going to be x is equal to h. Hello. All right, Ari, you got a shirt. We're going to be matching because I have the same shirt. Well, you and your mom and me, we're going to match. The graph will open up when A is, what do you think? You're going to go up when A is positive and down when A is negative. So the width, how wide your graph is, because sometimes your graph is just regular. Sometimes your graph can be really wide. Sometimes your graph can be really skinny. All of that depends on A, and A is the number in front of the parentheses. A lot of times it's a 1, and when it's a 1, it's just like that. You go over 1, 1 squared is 1. You go over 2, 2 squared is 4, and it's that pattern. But if the number in front of the parentheses is not 1, then it's either stretched or compressed. Sorry, stretched or compressed vertically. And the width, so this is the very bottom. The width is determined by A. It's the number in front of the parentheses. And when A is equal to 1, you're going to plot by squaring the x distance. That's how we plotted the parent function. I mean, even if it's not 1, you're going to plot it by squaring the x distances. That's how we're going to do it. So really, the squares that you have to have just really fast and committed to memory, you got to know 1 squared is 1, 2 squared is 4, and 3 squared is 9. I can't think of many other times where you're going to have to know more than that to graph quadratics. So we just got to know that. Let's see, we're graphing. Did I write anything? I don't know what I had to write here. I'm not sure. So first, we're going to identify the key features from the graphs and write an equation in vertex form. So vertex form, it looks like this. So our equation is always going to start out with y is equal to, I'm going to give myself a little break after the equal sign, and then I'm going to have some x, leave myself a little break. So I'm leaving myself a little space here, and I can write something after. Every equation will start out looking like that. We just have to figure out what the blanks are. So my second equation, I'm going to call this f of x because why not? I'm going to leave myself a little space, put the x, and something squared. Everything starts out like this. And whether you put f of x or y, doesn't matter. It doesn't matter. Whichever one you like better, you can write it like that. Doesn't matter. So we're going to go through and we're going to find all these parts. So starting out, yes. Yeah. I love it. -3, -2. Yes. -3, -2. Beautiful. Beautiful. Axis of symmetry. The y-intercept. Sometimes we don't know what the y-intercept is, so we can come back to it and do it last. If you see it on your graph, then fill it in. So like this one, can you see where it crosses the y-axis? At -3, we could write that down. This one is at 0, -3. It looks like 7, but once we have the equation, we're going to verify it and I'll show you that it works. Because some of the ones on your homework, the answers are really big numbers. So I want you to know how to find it. Axis of symmetry. I told you guys that the axis of symmetry is always x is equal to what? Look on your notes at the top of the page. X is equal to what for axis of symmetry? Yeah.
H.
Does it feel like you've learned it before? In Algebra 1, you did. In Algebra 1, you learned all this stuff. So it should feel familiar. Yes, x is equal to h. So that's important. X is equal to, what's my h?
Oh,
-3. So that's where that comes from every time. And then another thing that comes directly from the vertex point, you don't have to know anything else, is the range. So the range, or we know the domain already. What's the domain no matter what? All real numbers. It's always all real numbers. And I can write that on both of them. It doesn't matter what the range is. But the range depends on the k value. So for this one, it's y, and then is my graph above or below the vertex? Above. So when it's above the vertex, you say greater than or equal to. And it's going to be the k value. So the axis of symmetry is the x value or the h. And then the y value or the k, it's going to be for the range. So that's where these two values come from. So the y-intercept, we're going to come back to it. This one, we could tell what it is because it's a point on the graph. This one, it looks like it's 7, but we don't know for sure. So I'm going to show you how to check it. Is this graph up or down? It's facing up. And when it's facing up, it means that the A value is positive. And all you're checking for the A value every time is the very first distance. And usually it's a 1, but if it's not a 1, we just count. So for this one, if I go over 1, how far up do I go? 1, that's my A value. Now I'll show you how to do it over here. Is this one facing up or down? Down. So it's facing down, which means that A is going to be a negative. And so if I go over 1 for this one, do I go down 1? No, I go down how many? No, I don't. 2. So it's a 2. So it's always, you go over to that very first point. What's that y distance? That's what you're looking for. That's the A value. I have everything over here to write my equation, and they go in order. So I need to know my A. This is A, H, and K. So A is a 1. So a 1 goes right out in front, and it's positive, so I'm not going to put a negative. And then, so to write your equation, you need A, H, and K. So remember that the H is always opposite. So when I come put it in here, it has to be +3. It's always opposite when you put it in or take it out of the parentheses. So +3 and then -2. So you need A, H, and K. Do you think that on a multiple choice, is it going to have the 1 out in front? Probably not. So I'm going to take off the 1. You're probably not going to see a 1. If you want to put it, but you're probably not going to see it. All right, we're done. That is my equation. That was my whole goal. I have an equation. Beautiful. For my second example, what's my vertex? 2, 5. So I actually have everything that I need to write my, yeah. Oh, I'm glad you said something. Let's go add the y-intercept. So the y-intercept is when x is equal to 0. Okay, so let's pretend like this is a 0. What's 0 plus 3? 3. What's 3 squared? 9. What's 9 minus 2? 7. It is a 7. So it's not always, so it's 0, 7. You just plug in 0 for x. And you can literally just type it directly into your calculator if you don't want to mess it up. You have big numbers on your, or some bigger numbers on your homework. You've got double digit numbers. So just type it in if you want to. Over here. So to write my equation, all I need is A, H, and K. So I have A, H, and K. I have A, H, K. I can write my equation. So my equation, A comes first. This is a -2, so that's what goes in front of the parentheses. -2. H is opposite, so when it goes in the parentheses, it's going to be what? Yes, -2. And then I put K. K is just K. What you see is what you get, so +5. So I already have my equation. My point is you don't have to know all the other stuff to write the equation. All you have to know is a vertex and A to write an equation. But we can loop back around. So we know the vertex, the y-intercept, the axis of symmetry. What is that going to be? 2. X is equal to 2. Very good. And my range is the only other thing I need. Y is this opening up or opening down? Less than, because it's below. So less than or equal to what? 5. You put, when it's facing up, your range is greater than. When it's facing down, the range is less than. So again, H comes from here. And then, yes. So your vertex tells you your axis of symmetry and your range. If you put it, it's not going to make a difference. You can put, it's like X versus 1X. Same thing. Are we good so far? And when we're done with our notes, we'll do Family Feud. But since I'm videoing, sometimes it times me and it'll cut my video off. All right, we're on to the back page. So now we're going to work backwards. I'm giving you an equation and we're going to take that information and we're going to graph it. And so now that we know where all the pieces are on the graph, it should be pretty easy. The vertex for the first equation, what's my vertex going to be? 24. Very good. So my H is right here, my K is right here, and that's my A. So my vertex is 3, 4. Is this going to open up or down? Down, because it's negative. So it's going to open down. And the way we're going to figure out what we put, how far up or down we go every time we move over one and then another one and then another one. This is, no, it's opposite. Anything going into the parentheses is opposite. Anything coming out of the parentheses is opposite. Only the H value is always opposite. So the Y distances, the way that we're going to figure them out for this one, You write down whatever, this is going to be a negative, I don't know why this is writing in pink. Negative x squared. That's how we're going to figure it out. Instead of going over one and squaring it and going up, we're going to go down. But I'm going to talk you all through it. Before I even graph, you can tell me what the domain is. What is it? All real numbers. So I can go ahead and jot that down for that one and the next one, because I don't need a graph to tell you. The domain is all real numbers every time. Because you need to know that other graphs, it isn't all real numbers. You just need, that just means that it goes on forever. It's important to know that the graph goes on forever and left and right. Let's go plot our vertex point. So let's go plot the point 3, 4. We should be masters at this because we do all those fun mystery pictures. So I can plot points over 3, up 4. I've got my vertex. From here, the way I graph is always like this. I go over 1, I go over 2. If I can, I go over 3. And this is how I'm going to figure out how far up or down I go from that point. So this is my y distances. If I go over 1, well, what's 1 squared? 1. And then this just says make it negative. Instead of going up, I'm going to go down. So I go down and put a point. I'm going to go over 2. So starting from the vertex again, I go over 2. Well, what's 2 squared? 4. Now make it negative. So I got to go down 4. Able to do 3. So if I go over 3, what's 3 squared? 9. And this says make it negative. So I go down 9. So this would be the exact same thing if it was facing up, but because this is a negative, I'm making the points facing down. So I'm going to use symmetry, and I'm going to plot the points on the other side using symmetry. As soon as I've plotted my points on both sides, I'm going to make my curve, and I'm going to make sure it looks like a curve and not like a V. It needs to look like a U, not a V. Graph went a little bit crazy. Once I have my graph, I can identify my range. So my range, is it going to be greater than or less than? Less than, because it's facing down. And remember that it's directly from the K value. So 4. Let's make another graph. This can be fun stuff. So my next graph, I'm going to rewrite this and show you. Is there any parentheses here?
No.
No, it doesn't mean that they aren't there, but all this is it's the same thing as 3. And then if there was an x minus 0 squared minus 7. So we're not going to put a minus 0. So if there's no parentheses, then it means a 0 right there. What would my vertex be? What would my vertex be? So remember, H is what's in parentheses and K is what's after. This is my A. Yeah, 0, 7. Is this graph going to face up or down? How do you know? Because the 3 is positive, I am going to face up. So for this one, I'm going to do 3x squared. And you'll see what that means in a second. I'm going to plot my vertex. It's at 0, -7, -7, not 0, 7, 0, -7. So you're all down at the bottom, 0, -7. From here, I'm going to apply this for my distances. So I always go to the right first. So I go to the right, and that's 1. Well, what's 1 squared? 1. Triple it. What's 1 times 3? So you go up 3. Okay, let's do it again. So if we go over 2, what's 2 squared? I always do it. I go over 1, I went over 2, I went over 3. I will always do it every time I graph. So for this one, I went over 1. Well, what's 1 squared? 1, and you have to multiply by 3. So I went up 3. Now I'm going to go over 2. What's 2 squared? Now times 3. 12. That I go up 12. So I go over 2. 2 squared is 4, but whatever number I get, I have to multiply it by 3 because there's a stretch of 3. So I'm stretching it by 3. So whatever it is, times 3. So I go up 12. I go over and I do 1 squared, then 2 squared, then 3 squared. And if there's a number in front of the parentheses, I have to multiply that by that number. But on the first one, Aiden, example 3, it was just a -1. So I didn't really multiply by anything, but I just reflected and went down instead. So let me see. I can put 12. 12 is going to be all the way up here at 5. And now I'm going to make my points symmetrical on this side. I'm going to connect the dots and make it look as much like a U as I can. Sometimes when they're stretched, it's hard. And then I keep going. It's really stretched, but I do the best I can. Change. Is it going to be a greater than or a less than? Greater than, because my graph is above the vertex. And what's the number that goes there? -7. And you're going to get plenty of practice graphing. You have 4 graphs that you have to do. You have 4 graphs on your homework. Yep. Yeah. So these are all the ones that are written in words. Please don't skip these. These are easy. All you got to do is listen. You're going to figure out how to do it, and it's easy. So all that number 5 and 6 are doing is asking you to describe what those transformations would do. So anything that's in front of parentheses, that's going to stretch or reflect you. So that 2, it means stretch by 2. That's all you write down. Stretch by 2. Yep, but go fast because I don't want you to miss any of this. The next thing it tells you, this tells you left or right. When it's negative, it actually goes to the right. Right 3. And then this one tells you up 1. And that's it. That's all you're writing. That's it. Opposite. So what if this was a plus? Then you would go left. Very good. So over here, I've got a negative in front. Negative just means reflect over X. Reflect over X. Reflect over the X-axis. And then after the parentheses, there's a -4. So it's just like this +1. What's the -4 going to tell me? Down 4. That's it. So all you're doing is describing those transformations. For question 7 and 8, it's asking you to write an equation. Don't overcomplicate it. We know what the form of an equation looks like. It's going to be either f of x or y. And I'm going to leave a space. I'm going to have something x squared. And I'm going to fill in the blanks. Same thing goes with the second one. I'll do y equals because it doesn't matter if it's f of x or y equals. Either one works. And then I'm going to go through and I'm going to read the stuff. Okay. If there's a stretch or reflection, it goes here. Left or right goes in the parentheses. Up or down goes at the end. So let's read. Given the transformations, left 3. Okay. Goes right here. But what do I put? Left 3, what should be in the parentheses? +3. It's opposite. So if it says left, you go plus. And then up 1, where do I put that? On the right. +1. And then it did it say anything about stretching or reflecting? You're done. A 1 is there. You don't have to put anything. Same thing. Same thing. And I don't care which one you put. The next one, reflect over x. Where do we put that? Yep, it's going to look just like this. We just put a minus out there. Okay, and then it says right 6. What do we put here? I think I heard it. What do we put? -6. And then that's it. Super easy. All you got to do is write out what I put in black and then fill in any blanks that you have based on the verbal transformations it's giving you. Any questions over these? Down. You're trying to get me to do a homework problem, girl. I'm on to you. I'm smarter than that. That was clever. I almost told you. The last problem. Raise your hand if you like word problems. Only Aaron. That is it. He stands alone. He stands alone. Okay, here's the thing. Please don't skip the word problems when it comes to quadratics. I can almost promise they're some of the easiest word problems we're going to do. So this one says the parabola shows the path of a golf ball where x is the horizontal distance in yards and y is the corresponding height in yards. It gives you 3 points along the path. The first question, how far away is the ball when it hits the ground? Second question, what is the maximum height of the ball? And the third question, how far away is the ball when it reaches its max height? Answer those questions on your paper. You're writing in pencil, so just see if you could answer those. It's 3 questions. You put down a value. Let's see if you're right or wrong. Jaylee, did you already answer these? Jackson, did you answer these? They're too easy. Just go answer them. There's 3 points. No, they aren't all the same answer. No. Talk to the people around you. Sage, did you already answer these? Did you already answer these?
So why this is always negative x?
No, I'm increasing. Yeah, why? Yeah.
All right, let's talk about these. The first question, how far away is the ball when it hits the ground? 100 what? 100 yards. Good job. What is the maximum height of the ball?
A million.
So it goes over 50 and up 25. What's the maximum height of the ball? 25. Very good. How far away is the ball when it reaches the maximum height? So it had to go over 50 and then go up 25. How far away is the ball when it reaches its max height? 50. Was that difficult? What? You are capable. Don't sell yourself short. So mainly it's just knowing what these values do. We need to know that every time the X is left or right and the Y is up or down. I think that's just where you guys got confused, is knowing which one was which. All right, we're done.